Okay, so today's seminar is about fire-resistive construction. There are some variations on this presentation, i.e. there's some additional information regarding fire barriers and smoke barriers, fire walls, etc. We'll have another presentation about that at another time, although this one will give some examples of comparisons between the two. Construction fire resistance of construction itself for construction type versus fire resistance for fire barriers and or smoke barriers. I am going to make that comparison, but I'm not going to get into when do we use fire barriers, when do we use smoke barriers. That's a different presentation. But I will sort of compare the two, which is some questions that have come up recently that necessitate this. So what are some of the topics? We're going to cover construction types as to what are construction types, as required by NFPA 101 and the IBC. What are fire resistive assemblies? Talk about product and assembly listings as they relate to fire resistance or fire resistive assemblies. Where do you use certain items, certain assemblies, etc. And then some of the concepts of penetrations and I use the word inconsistencies of assemblies, because it's not a matter of always having a hole or something going through it, creating a hole. It's also a matter of making sure that your assemblies are consistent where they need to be to maintain the 1 hour protection of all of the 1 or 2 hour protection of all of the various construction portions of construction or the structural elements. Okay, so when I was a surveyor, I used this slide a lot when I was a surveyor to give some example of how bad this issue can get. And I did an 88 or is that 92? I can't remember anymore. Surveys total at the state. About 43 of them were initial brand new facilities. Some of them were second, some of them were smaller facilities, etc. But at least over half of those were initial surveys facilities that had to be rated, 1 hour or 2 hour rated. 100% had issues. I've never had a facility ever that when I was at the state or in the almost 5 years now that I've been at DFD, we've never had a facility ever that was 100% correct at the time of any inspection. Fire marshal, city, or state, didn't matter. There's always going to be things, and I can guarantee you, I can go through a facility 20 times, and I go back the 21st time, I'll find something else that I missed. And that's why in healthcare facilities especially, we have so many different systems, passive and active, that overlap each other. It's that redundancy that we rely on. Is, well, why do we have to do this if it's sprinklered? Because the sprinkler system is going to fail. You have to assume that. Okay, well, why do we have to do this why do we have to do the sprinklers so perfect if the fire alarm is always, because the fire alarm is going to fail. You have to assume that. So the assumption is that everything is going to fail in your building. So everything together that's not failing will provide the residents the safety they need, the time they need to get out. And we've talked about that in past presentations about the whole point of the life safety code is get everybody out. That's it. The building code actually cares about keeping the building standing in a hurricane, standing in an earthquake, etc. The life safety code, all it cares about is getting people out. But you still have to have time to get out, which means you still have to maintain the building for a certain amount of time, because if it comes down in 5 minutes, nobody's getting out. And then to give you an idea, 100% had 49% of this, so roughly half totally failed their first inspection due to construction-related issues. Fire-rated construction. This has nothing to do with fire alarm, fire sprinkler, has nothing to do with any of the licensing regulations. It's just rated construction issues, because they're the most expensive and most time-consuming to fix, next to emergency electrical, which can be much more expensive depending on what it is. And then 3/4 of them had issues that were big enough that we had to come back and do a revisit, or, because that would include the 50, or had to extend the survey for the next couple of days so they could fix more issues with JIP order, more issues with that kind of stuff. It's a big issue. Okay. Some basic definitions. Now, these are sort of my modified ones, but they come they're implied by the code, or I'm referencing it. Rated construction is that you're basically rating the structural components of a building. So you're talking your walls, columns, beams, girders, trusses, arches, roofs, floors, anything that holds something up. That is a structural member. You know, if your structural engineer has it on the drawings, it's structural. It's simple. So those are what we're concerned about when we talk about rated construction. I.e., if you have an unrated partition, if you have a low wall or you have a wall that is in no way carrying load, it has nothing to do with the rated construction. Now, construction type, we'll get into a little bit, does care whether it's totally combustible or non-combustible, and that because you can't, even if it's not rated, it still has to match the construction type. But when it comes to, do we have rated components to protect our structure, all we're worried about are those structural members, okay? And then depending upon the type of building you do, you may have a lot of structural members because all your bearing walls in a regular one story wood building, half the walls or more than half the walls are load bearing. You get into a steel building, none of the walls may be load bearing. So it depends on your structural system. Unrated construction, pretty straightforward. There's no rating. 0 hours on any structure whatsoever. The building will burn down very quickly if the fire is not suppressed by other means. For reference, all of DAD's facilities, all the ones that are licensed in the state of Texas by the Department of Aging and Disability Services, must be fully sheathed, i.e. you cannot have exposed studs anywhere in a facility licensed by DAD's. Even in a conversion of a home to a small A facility, which is not something that we do as a firm very often, you have to at least have gypboard. You can't just put up P111 siding on the inside of your walls and call it good. You can't. At a minimum, you're going to have to put up gypboard. Nobody sells, well, they do sell 1/4 and 3/8, but typically you're going to see 1/2 inch or 5 inch gypboard. So as a rule of thumb, all of our facilities have 5/8 inch gypboard, period. Even if it's not rated, we do 5/8 inch gypboard because it's a minimum sheathing requirement. Okay, this is the big question that everybody has in terms of, okay, what the heck's construction rate? I have things I need to rate for construction, and I have all these fire barriers, I have smoke barriers, smart partitions, I have fire walls, I have all these different kind of rated components. But then what do I do with those? But then you're saying I got to rate all my bearing walls, and I got to rate my exterior walls, and I got to rate the girders and all that. Okay, construction ratings, which is per your construction type, which I'll get into in a second, is to keep the building standing. Has nothing to do with preventing the passage of smoke or fire to going through, past, around, in any way, shape, or form. All we care about is the building staying up for the prescribed amount of time. 1 hour, 2 hour, that's pretty much it. There really isn't a 3 hour in terms of total time for the building. There are some building types that require 3 hour components, but they generally are because the other components of the building are less than 3. So most of the ones we do are 1 hour because we typically stay below a certain number of stories. But the whole point is you can't get out of a building if it's falling down around you. But so if your bearing walls are required to be 1 hour, you have to keep them from falling apart, i.e. fire cannot get into or affect that structural member for 1 hour. It has to stay standing. Somebody standing on one side of a bearing wall where there's fire on side of the other is going to get burned. It has nothing to do with the fact that it's a bearing wall. It's not meant to protect the people directly. It's just meant to protect the building for 1 hour or 2 hours, just to keep it standing, because that's one of the components you can't get out if the building's falling down around you. Then you'll have fire and smoke barriers, fire walls, smoke partitions. Those are intended to separate corridors or separate exits or separate sections of the building into smoke compartments or separate hazardous areas from other areas. The whole point of those is they are to separate. Those kind of barriers, you do not want fire or smoke to get past them. They may not be load bearing. It has nothing to do with that structure at that point. Those components, those walls, and generally they're walls, but they can also be floors, because every floor in a healthcare facility is also a smoke barrier, a 1 hour rated smoke barrier. The intent is to compartmentalize, to keep the smoke and fire in a certain area to give people time to get out around it. But the two may coincide with one another. You might have a smoke barrier that is also a bearing wall, so it must stay up for 1 hour and nothing can get past it for 1 hour. So it's two different things. But you might have a a bearing wall going down, say, both sides of a corridor. In a nursing home, we do this all the time, where your exterior walls are bearing and your corridor walls are bearing. But in a nursing home, which is an I2 occupancy under the IBC, your corridors are only required to be resist the passage of smoke. They're called smoke partitions in the IBC. They don't even have a definition in the life safety code. They just have to resist the passage of smoke. Well, they might be an hour rated because they're bearing walls. They got to stay up. But because they're not a fire barrier, meaning they just have to resist the passage of smoke, the doors in the resident rooms, which is usually the doors that are in our corridors, they're unrated. They just have to close securely in their frames, keep the smoke out. That's it. They're not self-closing, they're not automatic closing, and they're not rated. They're basically equivalent to a 20-minute door in construction. They're 1 3/4 inches solid core doors, but they're not rated because the wall is not rated for the purposes of separation. The wall is rated because it's a bearing wall. Now, if we had a truss that went from exterior wall to exterior wall, they wouldn't even be rated. But because they typically bear on a corridor, it ends up being a 1 hour rated for that perspective. So you have to treat it and keep the fire out of it. But you can let fire go through the wall. But, they're supposed to be smoke partitions, say, on a corridor in a nursing home. You do have to keep the smoke out, but that's not a rating. There's no rated assembly for keeping smoke out. If you build it as a rated wall, chances are the smoke will stay out. But that's the defining line. When I did a lot of educational work, elementary, middle, and high schools in the state of Florida, and we would do tilt wall construction. At the time, we were required to have a 3-hour rated exterior bearing walls for the type of construction we were doing. And it was a mixture of concrete tilt wall exterior panels with a steel frame on the inside. So the steel frame is bearing on a 7 1/4 inch thick concrete slab. Well, those were 3-hour rated bearing walls, but the corridors were 1 hour rated. So the drawing said 3-hour construction and 1 hour bearing walls. And then the doors were 45 minutes because it was a 1 hour corridor. This is educational, so it's different than healthcare. So we called out 45-minute doors. The contractors were freaking out because they thought they needed 3-hour doors in a 3-hour wall. It's like, no, the 3 hours is the construction rating, which 7 1/4 inches of solid concrete provides us 3 hours of construction. It's not going to burn down in less than 3 hours. But we only need an hour of separation. So it's 2 different reasons for having a rating on a wall. Okay, so that's talking about ratings, and that's talking about the difference in construction and barriers. When we get into construction types, you have non-combustible and combustible, and it's really important to understand that. And some of this has changed, not the definitions, but what's allowed has changed. In nursing homes, we've gone from the 2000 edition of the Life Safety Code to the 2012 edition for federally funded nursing homes, and actually in the state of Texas for all of them. So non-combustible material, and this is not fire resistant, this is just non-combustible. It doesn't burn, doesn't support, doesn't ignite, it doesn't support combustion, it doesn't start combustion, it just doesn't burn. So non-combustible, you can think of a lot of things: concrete, steel, Portland cement, plaster, all those things don't burn. They're not resistant to fire. Good example that I use all the time is Hardy Plank is the brand name, or cement fiber, cementitious fiber siding. It's made up of fiber, it's got some wood fibers in it, but it's Portland cement with reinforcing fibers. It doesn't burn. You can try burning it, it just blackens and doesn't burn. But it's not fire resistive. It does nothing to prevent the passages of fire, because when you burn it, it gets brittle and it falls apart, like most concrete would in that thin form. But it's also non-combustible, it doesn't burn. So the two are very different. They're not, non-combustible and fire resistant are not the same things. The other one is material, you hear what's called a flame spread rating. That is, how will it burn across a surface? Flame spread only has to deal with surface materials. So you're talking flame spread of wall materials or curtains or any of those kind of things. There's different testing depending upon whether they're loose hanging or they're on a wall or on a floor. But flame spread is a totally different thing than whether it burns or not. Flame spread is how much will it burn across the surface. non-combustible, doesn't burn. None of that means that it's fire resistant whatsoever. Okay. Construction types, and this is directly correlated to the healthcare industry here in Texas, and that is, so in nursing under the 2012, you have Chapter 18 and Chapter 19. Assisted living facilities in the state fall under the 2000 edition, and talks about the exact chapters for those. But under NFPA 220, and then there's a very similar table in the IBC that talks about construction types as well, that tells you basically, okay, each construction type has certain ratings for each structural member. So type 5000 in NFPA 220 is any material permitted under the code, any, combustible or non-combustible, and has 0 rating. Your typical residential house. I mean, honestly, most buildings are probably fit under type 5000. You can technically have a steel building that is type 5000 if you put wood in it somewhere. If you're only required to have type 5, you don't need to call it anything else. Type 5 is any material permissible under the code. Any of the areas that are in gray are allowed to have combustible materials in the construction of them. If it's not in gray, it's totally non-combustible. You can't have anything combustible. Structural or not, it can't be combustible in the building. So type 5, you have unprotected, which we call 000, and we call it unprotected. Type 5, 111, don't get caught up on the 110, 211. You go by the chart. Whatever it says you have to do under the type, that's what you do. It just uses the nomenclature. In the IBC, it's A and B. They'll use type 5, A and B, type 4, A and B. In NFPA 101, in NFPA 220, they use 111 and 000, and that's how they define them. They're identical. 5A and 5111 are the same thing. So they're both 1 hour, anything under the code. The ones we use the most of, and I go in here a little bit, so the typical we use are type 5 and type 2. Type 5 is anything you want to use. Well, we use wood, construction falls under that. Our typical wood frame building is type 5 because it's anything totally comprised of wood or any other material, and it's either unrated or rated. And then type 2 is all non-combustible, unrated, 1 hour rated, or 2 hour rated. That's what we typically use. And type 2 is going to be your all steel buildings or all concrete buildings. And so you'll have no wood construction whatsoever in a type 2 under the 2000 edition of the Life Safety Code. In the 2012, there is one small little change, and I'll mention that. But it's, as a company, we don't do it because it's too confusing. Less common, you have 1, 3, and 4. 3 is usually called normal construction. Those are familiar with 6th Street with concrete or stone bearing walls on either side and wood in the middle. That's type 3 construction. Type 4 is heavy timber. We don't see a whole lot of real heavy timber in Texas because the trees just aren't big enough around here. You can now, in the 2000 code, you're not allowed to mix between any construction type. I.e., if you're using type 5, you can't use heavy timber. Well, it's like it's heavy timber, so I can. No, under the 2000, you can't mix and match. You can't just use one from one type and another. It's all or nothing, period. If it's wood, it's type 5, period. So that means if you have a 20 by 20 column out of solid Douglas fir under type 5, you are putting gypboard on the outside of it. Talk about a shame to do that. Under the new version under the 2012 edition of NFPA 101, it references a newer version, the 06 version of NFPA 220, which is the construction types. It permits you to use heavy timber members as long as they meet the sizing requirements of heavy timber in type 5 construction without providing additional protection, which means we can do, connected to the building, we can do all the heavy timber porte-cocheres that we've always wanted to do. We can do heavy timber trusses inside the building, etc. I still have to meet flame spread requirements inside the building, but you can mix heavy timber into type 5 construction. You can also mix it into type 2. I have to go back and double check that, but I think you can also mix it into type 2. I might be wrong on that one. Type 5 for sure. The other one is fire retardant treated wood. Fire retardant treated wood is combustible. Don't let anybody tell you otherwise. It still burns. It burns really slow, but it's chemically treated so it doesn't burn as fast, but it is still considered combustible underneath the definitions in NFPA 220. That 06 edition of 220 permits FRTW plywood in a type 2 building. So it says you're allowed to use it. So you could do roof sheathing on an all steel building using FRTW plywood, which is really expensive. We as a company are not going to do that, plain and simple. If you're doing a steel building, we're doing a steel deck, because then it's all non-combustible, and we go that, and then it's just no arguments whatsoever. Under the 2000 edition, you could not do that, and there were a lot of facilities that got in trouble for trying, because they were looking at later editions of the code that were not adopted yet. Okay, so different construction types, and this is really important when we're talking about additions, and that is structures of different construction types must be separated by a 2-hour fire barrier per the NFPA 101, the Life Safety Code, or by a 2-hour fire wall according to the International Building Code. Well, in the state of Texas, we must meet the IBC, therefore different construction types must be divided by fire wall. 2-hour fire wall, and that is an independently supported or double 2-hour wall to separate the two construction types. It is always vertical. You cannot have a multi-story building with different construction types stacked on top of each other. I can't have a wood building on the first story and a metal building on the upper story and call it that I'm good. No, when the first floor turns, the whole thing's coming down. And it's very clear in both the building code and the International Building Code, the Life Safety Code and the building code. It's vertical separation, never horizontal by construction type. Occupancies can be separated by a horizontal barrier. Types of construction or separating a building into multiple buildings because it's too big, always vertical, never horizontal. And trust me, people have asked or tried to do it. Typical of what we see all the time, a large type B assisted living, this would also be in nursing. This tells you what's permitted and what's not permitted in terms of construction types. You can see real quickly, you can't do healthcare, wood, unprotected. It's not permitted. You can do a 1-story type 2, 00, oh, this one's, yeah, type 2, 000, where am I at? Right there. You can do an unprotected, no rating, all non-combustible healthcare facility. So all these 1-story nursing homes and 1-story assisted livings that we do, they could technically be all done out of metal studs or all steel and have no rating whatsoever. But it's a lot more expensive than in wood construction. So typically that's not what's done. But as soon as you go to multi-story, you have to go to non-combustible. You can see under 2 stories, 2111 is the lowest type of construction that you can do in terms of rating for a healthcare facility. And now under the 2000 code and the 2012, and actually in the United States in general, they all must be fully sprinklered. There's no exception whatsoever for healthcare. So what is a fire resistance rating? It's the time, minutes, and hours that that particular assembly, as described and tested in certain exposure tests, will last. So those are the 3 standards against which they're tested. These are the procedures under which they were tested. This is not the agency. This is not the 3 on the left, that's not the agency, that's not the testing person, that's not anything, but this is the instructions of how to test it. You must have a furnace this big. This is how you put it. This is where you put the thermocouples. This is how long you test it. This is how you document the testing. Anybody can go build this in one of their backyards if they have a lot of money, a lot of space, and are that hard up to build one themselves. You're welcome to. Any independent testing laboratory can go out and do this. We know UL, which used to be called just Underwriter Laboratories, which is now just known as UL, one of the most common things. There's no requirement that anything has to be UL. It just happens to be the most worldwide known testing laboratory. But you used to have Warnock Hersey, which was bought out by Intertech. You have Intertech, Factory Mutual. Used to have Omega. Omega was bought out by Intertech. You have a whole bunch of other testing people, or testing companies. Any of them can meet these. They just have to test it per one of these 3 standards. One is an NFPA standard, which is really being phased out because the other 2, ASTE 119 and the UL one, are more heavily used now by any testing agency. They all have the same requirements. If you test something per it, now you're going to go to UL, you're going to pay your money, your thousands of dollars, you're going to say, this is the assembly we want. This is how big it is. These are the components. These are the exact products. This is how far apart we want the screws. This is how long the screws are. They build it, put it in the furnace or above the furnace, depending upon what kind of it is, and they burn it. And they say, oh, and we want it to last 1 hour. They test it for 1 hour. Great, it passed. They stop the test. They don't burn it for as long as they can and say, oh, let's see how long it lasts. No. You want an hour, you got an hour. If you want it for 2 hours, great, we'll test it for 2 hours. If it doesn't meet 2 hours, nope, doesn't pass. Once it's passed, then they describe basically the assembly that passed. That is now the assembly that goes into UL's directory of assemblies. So everything that's in there has physically been built and tested in a laboratory, and it has passed the test. You can't interpolate that, well, that passed, so then this one will. If it hasn't been tested, you have no documented evidence that it will pass or ever will actually last like it's supposed to. Like I said, there's a lot of different ones. There's also a lot of different places you can get those assemblies, because a lot of other agencies such as the ICC, International Code Council, as well as the Gypsum Association in the United States, publish assemblies that go along with, they actually reference tested or tested assemblies. If you go into the Gypsum Association's Fire Resistance Design Manual, you'll see under each of their GA, RC 2602, whatever, it'll list the various tests, whether it was a factory mutual test that was done in 1979, or they'll reference a UL assembly. So they're really sort of copying the two, and I'll take some questions after we're all done. So the key component to those fire resistive assemblies, you cannot remove nor substitute and must use all of the components as listed. No ifs, ands, or buts. If it says optional, okay, don't have to use it. If it tells you you must use this particular gypsum board, you must use that particular gypsum board. You cannot in any way substitute unless it allows substitutions or various alternates, because that's what they tested it. So let's say P522 or P544, which is a typical roof ceiling assembly. It lists 4 different gypsum boards, 4 different products. That's what they tested it with. They didn't test it with another company's gypsum board. You can't use it, plain and simple, because that's what was tested. That's what's in the assembly. That's what you use. Also, you can't just add anything you want to it. You can't go and add additional layers of some things. You can't go add, I want to go and add, some kind of flammable material to the inside of a rated assembly that's not otherwise permitted. It actually may decrease the ability. Good example is in some assemblies, in the roof ceiling assembly, if you put the the insulation against the roof deck, it has one requirement for the construction. If you put it against the ceiling, it has a different. The channels are spaced closer together. Why? Because it heats up the ceiling faster. So depending upon what's in there and where it is in an assembly, it can affect the fire resistance. A couple things that are different, however, or clarifications, you can always add more gypboard. That is one thing that they say in all these assemblies, the ICC and in the Gypsum Association's directory. If you want to add 18 layers of gypsum board to a 1 hour assembly because you want to do it for, say, an STC rating, you want to do it for sound prevention, go right ahead. More gypboard will not lower the resistance of a fire resistive assembly. And I give this one because it has to be done per the assembly. If the assembly says to tape and float with joint compound all of the joints, don't seal them with fire resistance or with fire caulk. It didn't say do it with fire caulk. Don't do it with fire caulk. It says to do it with tape and float the joints. It also says probably to use joint compound on all the screw heads. Well, here's an example of one that a particular surveyor or inspector said, no, I want them all sealed with fire caulk. So they used a product that was not in the assembly and didn't tape and float or cover any of the screw heads with what was required. So this in no way meets the assembly as described, even though the inspector said, I want it that way. Well, he was telling them to do something that was never tested. Nope, they didn't never test it with fire joint fire sealant between all the joints. We've talked about this one in the past of there's no such thing as type C board. They are not equal. That type C board is actually really it's used as a marketing designation now because UL has their type designations for each individual product by various different manufacturers. USG makes a Type C, American Gypsum makes an Type AGC, Temple Inland makes a Type TGC, which is now Georgia Pacific. You have all these different ones. When they are tested with a very specific type of board, such as these improved Type X boards, you have to use that board. End of discussion. You can't modify that in any way. And actually what led us to some of this, USG actually has a really good paper, and I think I've given it to most of you. This is the white paper. This is on USG's website that talks about that Type X versus Type C, that they're not all created equal, because there's no such thing as a Type C in ASTM standard for gypsum board. It doesn't exist. Every manufacturer has their own improved Type X. So you can't just tell a contractor, oh, use Type C. When you say that, you're saying use USG's sheetrock brand Fire Code Core C gypsum board panels. That's what Type C is. It's not made by any other manufacturer. If you say, I want you to use Type FSWC, okay, that's a different, that's National Gypsum's, sort of their version of Type C. But there's no such thing as just Type C. So you should never ever put on a drawings Type C, ever. Because either you're going to put the whole product, or you're going to reference the assembly, or vice versa. But there's no such thing as just Type C unless you're using that actual board. And we've gone over some of these before. What are some of the typical fire rated assemblies? In a 1 hour, for 1 hour walls, in a 1 hour rated bearing walls in a wood structure, 1 layer of Type X 5/8 inch thick gypsum board. There are assemblies that say any classified 5/8 inch thick type gypsum board, 1 layer each side, is a 1 hour wall. And if it says any classified board, that means that any board that UL has considered classified, which is X, which is rated. You could use any single one, anything you want. But there are also those that say you must use just this board for a wall. Like you have one choice. Well, if you choose to use that assembly, you must use that gypsum board. So the ones that we typically use, U305 and U301, there's a whole bunch of them that allow for a wide variety of gypsum board on a wood stud wall. On a metal stud bearing wall, again, the 1 hour, there's fewer assemblies. So you really got to be careful about making sure that you have the right gypsum board for that one. And obviously we talked about girders, beams, trusses, columns. Everything has to be protected independently unless otherwise exempted. If you have a beam that supports nothing but your roof, as long as it's encapsulated within that roof ceiling assembly, it doesn't need to be independently protected. That's one of those unusual conditions. Otherwise, columns 100% protected inside the wall, if they're in a wall, top to the bottom of the column. I don't care if it's in the attic. It doesn't matter if it's more in the attic than it's not. The whole thing is protected all the way up. You cannot stop it. Bearing walls, bottom plate to top plate. The top plate could be in the attic. Doesn't matter. If you were to take that wall out of its current situation and it's only got gypboard halfway up, it would fail in the furnace. That's the way you have to look at it. Is that if you were to take whatever that element is, separate it out by itself, if you didn't protect it per the assembly for the whole thing, it would fail if it was tested. Because it wasn't tested in an attic. It was tested on its own up against the furnace. So you have to go bottom plate, top plate, column is the base plate to the top of the column. And the beam is, is the entire beam. The only exception being one floor or one roof, as long as it's encapsulated within that roof ceiling or floor ceiling assembly. The exception to the rule in terms of assemblies has always been solid wood members, columns and beams. There's never been any assemblies, specifically in the UL's directories or in the Gypsum Association Fire Resistance Design Manual, that talked about the protection of wood beams and columns. When I was at the state, we found a white paper by the USDA, the forest products, that talked about testing they did on solid wood beams. So we've been actually referencing that white paper. Well, in the 2012 edition of the Gypsum Association's Fire Resistance Design Manual, they now have protection of wood columns and beams in their manual, and they directly reference the exact report that we had been looking at for the longest time. But they also have 2 other reports that they're also basing it on. Same thing, 2 layers, 5/8" type X, directly attached to the wood column or the wood beam. So it goes with what we've always accepted as okay. It's now in that Gypsum Association's Fire Resistance Design Manual, which the IBC references directly and says everything in there is as included herein. So it might as well also be in the building code. And actually, no, it is, because it's directly referenced. So now 2 layers is official. We're not just making it up or basing it upon a report. It's now in one of the industry recognized ones. So we've talked about that. You cannot mix roof sealing and floor sealing. If it's floor sealing, it's only for floor. If it's for roof sealing, then it's for roof. And if there's products that are tested for a floor but not for a roof, you can't use them in a roof. A lot of those 10 mat covers for recessed lighting, the gray ones are for tested only in floor sealing assemblies. And the red ones are tested for 2-hour floor sealing and 1-hour roof sealing. But you see people all the time, well, it's 1 hour, we're good to go. No, it's only 1-hour floors, not attics. So it's really important that you do not mix up the assemblies nor anything that goes in between roof or floor. And we've seen our assembly, what the assembly is. This is P544, which we use all the time. You've got to follow it to the T. That includes spacing of all of the members, when you do and when you don't use them, what the manufacturers are for the dampers, what exactly models they are, how big can they be, how close together can they be, how many of them, what's the square footage you can have in one room or one area of those dampers. You've got to follow it exactly. So depending upon which manufacturer of damper you use may change your assembly. They all have to work together. Going for no substitutions is very, very common now because of the intricacies of meeting those. That's P544. You're very used to seeing it. It's one layer. In this case, it is allowed to be USG Type C. It also, I think, for P544 also allows AGC from American Gypsum on channels, on resilient channels, half-inch space, 16 inches on center. If we have, in this particular picture, we have insulation at the deck. If we had it against the ceiling, they'd have to be 12 inches apart because it would actually heat the ceiling. So you're seeing, wood trusses, 2 feet on center. The channels are screwed in, and then this is how you can always tell whether or not they have the right board up there. Is look for that UL stamp. It's on the back of every single board. If it doesn't have a UL stamp or it has the wrong one, you got a problem because you got the wrong board and don't have the right assembly anymore. Now you have to either make sure you have an assembly that matches what you have, or you may be ripping something down or adding something to it to now meet a tested assembly. This is the metal version of the same one. This is P550, which uses 7/8 inch hat channels because it's spanning 4 feet between each metal truss. Same basic idea though, 16 inches on center, a very similar proprietary board that's attached to the bottom. Some of these actually require, instead of screwing to the bottom, they actually require wire ties to tie the channels to the trusses. And believe me, it's really hot to go through those attics in the summer. Gloves are really important so you don't burn yourself on the metal. Continuation, I talked about not just holes in them, but continuation of them. Every time the ceiling does this, up and down, if you have different ceiling heights, but you're looking at the side of a truss, it says you must provide 1 hour, the NFPA 220 says 1 hour protection of all roof structure. Doesn't matter what orientation it's in. It can be vertical, horizontal, or anything in between. If it's roof structure, you must protect it for 1 hour as a roof ceiling assembly. So we do, and I'll show you in a second, but that includes all the bulkheads. So just because it looks vertical, it looks like a wall. No, it's not. If it's roof structure behind it, it's a roof, and you must treat it that way. If it's a bearing wall that you're looking at, and it's in the attic, well, then you better treat it as bearing wall, and you better have gypboard both sides all the way up it in the attic. So depending upon so if I'm standing in the living room and I'm in a big facility and I'm looking up at I see walls and I see a double top plate, and then I see, pardon me, I blocked my microphone. Then I see trusses on top of that double top plate, but the ceiling is still another 3 feet above. I have bearing wall and roof ceiling in the same plane. Well, they've got to be treated according to the assemblies. So one might have channels in one layer, one might just have one layer. Well, now I got an issue because they stick out from each other. So you either have to plan for that ahead of time, or you're going to end up with this big band of 2 layers or a big band of channel with layer. But just because it changes orientation, people think wall, vertical, ceiling, horizontal. No. Is it roof structure or is it walls? Is it actually bearing wall? Because when the bearing wall stops, it's not wall anymore, now it's roof. Or it's roof ceiling assembly. So this is a good example of like going down a corridor, we have popped up areas. Just because it's vertical doesn't mean it's wall. It's actually roof ceiling because it's the side of the trusses. So it must have the same channels spaced the same way. Or if you use a different assembly, it's like the one from the Gypsum Association, which is 2 layers, RC2602. I'm sorry, RC2601. Then, okay, you can use that one because it's 2 layers, but it's still a roof ceiling assembly. It's not a wall. And a good example, okay, looking up at this on the right-hand side, and I won't tell you whose project this is or where it is, but those look like walls. And when the uninformed gypsum, rocker, the guy putting up the gypsum board goes, it's a wall. So he puts up one layer on the inside, we're good to go. No, it's a roof. Because everything around it, what you're looking at behind it, what you're looking at in the left picture, is actually the structure. It's all trusses, all the way around it. Well, they needed the channels, the correct gypsum board, etc. In this particular case, they ended up having to come back and treat it as bearing walls. And it took a lot of work to get that thing to be 1 hour rated, because it's still protection of the roof structure, even though it looks like they're walls, but they're not. This gives you a good example. Okay, we get a lot of unusual truss profiles in corridors and etc. So when you were to look at this, if we had, and this one doesn't show the bearing points, right? But let's say there's a corridor wall right here. So the bearing wall would be right there. So you go, okay, well, it's 1 layer. Well, that looks like just wall as you keep going up. It's not. That's truss. That's roof truss. So they must be protected. This thing has to be protected its full length as a roof ceiling assembly. So this face right here, it might have a bearing wall under here with 1 layer of type X, but this one here is either going to have 2 layers of type X to meet one assembly, or it's going to have the channels with that proprietary board. So it's not going to be the same thickness. So the truss has to pop back, or you're going to have something stick out. But just because they're in line with each other does not make them the same. They're different. A roof is different than a floor, or than a wall is, and it's different than a floor, it's different than a column. Okay, and then I'm not going to get into a lot into the penetrations, but basically, if you put a hole in a rated wall, and it doesn't matter whether it's above or below the ceiling, you've killed the wall. A pinhole in any rated wall will allow smoke to just shoot through. Because when air heats up, you get a higher pressure. So the side with the smoke and the fire, and you get a pinhole-sized hole, will literally just a jet engine of smoke and fumes going right through that hole. Because you have high pressure on one side and low pressure on the other, and it just goes right through the wall. So the tiniest of penetrations will cause either the wall to be damaged in terms of falling down earlier, or allow all that fire, smoke, and gas to go right through the wall and totally defeat the purpose of having it in the first place.
Okay, well, it appears that I lost video right there at that slide. So instead, I'm going to go ahead and finish the presentation using just slides. So the rest of this presentation deals with protection of the openings and penetrations through those fire-resistive assemblies. This is really its own presentation, or will be its own presentation in a future seminar regarding fire stopping and protection of openings and penetrations. But I wanted to just go through some really basics and give you sort of a real brief overview of what is in itself a substantial issue when it comes to fire-resistive construction, both for rated construction and for fire barriers, smoke barriers, partitions, etc. So basically, when you've got an assembly that's been tested in a furnace according to one of the 3 standards that I mentioned before, UL 263, ASTM E119, and NFPA 255, those are done with no holes in the assembly. So they're not tested with anything going through it. They're not tested with holes or light fixtures and pipes and all this other stuff. So they all have to be independent. it won't last if you have holes. I mean, you get a hole through the wall, there's no doubt fire and smoke is going to get through it. That assembly will not last through a fire, it'll fail. So both the IBC and NFPA 101 Life Safety Code require the protection of openings through the assemblies. They're termed either through penetrations or membrane penetrations. Very simply, through penetrations go from one side to the other side. In a wall, it's going to be pipes, ducts, wires, other things of that sort that enter the wall from one side, exit the wall on the other side. Now, they are, if something goes into a wall and then comes out of the wall like 5-6 feet below it, it's actually two membrane penetrations, which is an opening in one side. The vast majority of penetrations are actually membrane penetrations, because in a ceiling or in a floors would have through penetrations, but in a ceiling membrane where you've got roof ceiling assembly, the other side of the roof ceiling assembly is an unrated roof membrane. So there's no such thing really as the through penetration of a roof ceiling assembly, because there's nothing rated on the other side. But membrane penetrations are simply those things that are only in one side of the wall. Through penetrations in floor ceiling assemblies have to be fire stopped and classified for protection as a vertical opening. So when you have an opening in a horizontal assembly, so like a rated floor in a multi-story building, you actually can protect it in a number of ways. If it's a big enough hole, you may not be able to do fire stopping. I mean, like a hole like an elevator shaft or a stairwell or something else of that sort. It technically is a vertical opening. It's an opening in the structure, in the floor, which may be a smoke barrier, fire barrier, or just because of the fact that it's a 1-hour floor assembly for construction rating. But it has to be either treated as a vertical opening according to the sections of the code, IBC or NFPA 101, treated accordingly. Or if it's smaller, like a pipe or a duct or something other penetrating item, not an open hole, then you have to use fire stopping that is tested for a horizontal application, or rather the member going vertically through a horizontal assembly. And then all of these penetrations and fire stopping such has to be, they all have to be installed, i.e. the products used for fire stopping have to be installed per a tested assembly. People get so tired of the word use assembly. If you don't have the instructions of how to put something together, or you don't have the instructions of how to apply something, you can't do it appropriately. You can't do it correctly. Everything that's been tested, either fire stopping or these fire resistive assemblies, the manufacturer gave instructions to the testing agency to describe exactly how to build the assembly, or to build the fire stopping assembly, or what product, how to build it, what manufacturers and products, and how far apart things are, and how long the screws are in the gypsum board, and how are the joints treated, how are they not treated, how's the insulation. All this stuff is instructions to the guys that just tested it, the people that tested. And if you don't follow those same instructions building it in the field, then you didn't actually build what was tested. And that's the key, is that unless you personally want to take the liability for doing this on your own, forbid that you ever end up in a court of law over something of this sort, I'm sure any responsible professional would prefer to say, no, I built it or designed it according to these tested assemblies. I didn't just make it up on my own. So it's really important that all these products and all these assemblies are done exactly per the manufacturer's instructions and the testing company's instructions, i.e. it's done per the tested assembly. So here's a list of, it's by no means a comprehensive list, and there's so many specifics in terms of the requirements to protect the openings created by these various kind of items. However, this is just sort of a good primer on what what openings and penetrations really are in a wall, and a lot of these people don't think about. Obviously, holes in a wall. That means holes that have nothing in them. And there are very specific processes or ways in which you need to patch holes in a rated assembly and or fill them. And you can't just sort of what we call scabbing on additional gypsum board over the hole and just screwing it into the gypboard, or even worse, gluing it onto the gypboard. There are actually the Gypsum Association in their fire resistance design manual talks about it, as well as they have their own white paper discussing how to appropriately fix or patch a hole on a fire resistive or on a fire rated wall or fire resistive construction, including a ceiling. So if you need to follow the actual instructions by the manufacturer and or the instructions according to the Gypsum Board Association. And then some other things that you typically would see: pipe, conduit, wiring. People are used to that. Electrical boxes, both low voltage and 120, 240, or 208, etc. The stuff that we would typically use in a commercial construction project. And metallic and both metallic and non-metallic boxes. UL, who's typically, there are other testing agencies, like I had mentioned before, that do classification or rather listings for various products. But UL does the majority, at least that I have seen, metallic and non-metallic electrical boxes. We're talking 4x4 or your typical single gang, which is like an inch and a half, 2 inches by 4. And the metallic boxes actually all have their own listing. They're all grouped together as a single product. And then they have, there's a guide info by UL that tells you exactly what those listing requirements are. And then each of the manufacturers and products for non-metallic boxes all have their own individual listings, pretty much the same requirements for installation and to make sure that they're rated. But each one has its own listing. And so you need to go to those particular products to find their exact requirements. There's actually quite a bit more into electrical boxes and protecting those, so I'm not going to get too quickly into them or too much into them. Things like recessed electrical panels. There's no such thing, not that I have seen yet. I would love somebody to show me one of an actual fire rated or electrical panel board that's classified for installation in a fire resistive assembly. I haven't seen one yet. And so I'm not talking about the 4x4 boxes, but the actual electrical panels, the big stuff. At this point, everything I can see needs to be surface mounted on a rated assembly and not recessed. Recessed lighting fixtures is that's a huge issue. You have so many recessed cans and other fixtures that put holes into a rated assembly, and they just don't. There's very few of them that are actually fully rated. There's a lot of new products on market now that our firm especially is using a lot of LED surface-mounted fixtures that the driver and the electrics will actually go into a 4x4 box in the ceiling. Then so the 4x4 box itself takes care of the rating issue of plugging the hole, and then therefore the light's not actually causing an additional hole. That's getting very, very common in a lot of the institutional projects, nursing and hospital and other healthcare stuff. But they're actually getting popular in homes and other places as well. You can still get rated light fixtures. They tend to be just much more expensive, and they have to be installed exactly per their listing, which can get very time consuming and expensive. Recessed heaters, recessed speakers. Heaters you don't see heaters too often as an issue. Until it's like a heat lamp or something like that, and there aren't too many rated heat lamps, not that I've seen. That can be recessed. Excuse me. There's plenty of them that are surface mounted, and then speakers. Boy, that's a big one. IT people, and I'm sorry, I group them together saying this, but usually in a project, you have your IT, your speakers, and your sound systems, and all that kind of stuff is done by owners' representatives or owners' contractors, subcontractors. And this very often you put an 8-10 inch speaker into the ceiling, cut the hole, put it in, you're good to go. No, it has to either be classified for installation into a fire resistive assembly, which I have never seen a speaker that is on its own, or it has to be covered with something, and that cover has to be a tested product, a tested fire stopping assembly. So we typically either do we call a box over the top of it, which is really a recessed ceiling, or it's a popped up little ceiling, just like the kind of stuff we do for light coves and pop-ups in a corridor, but it's much smaller. You pop it, and so you basically take that roof ceiling assembly membrane up and over the top of the speaker, and then the hole that's cut down below is essentially an unrated little section of that ceiling. TenMat also makes, that's TenMat, makes a product, a fire rated cover for light fixtures in a 1 hour roof ceiling assembly. They make them for 1 hour floor ceiling assemblies as well. They're gray and or black in color. The ones that go into a roof ceiling assembly 1 hour they're also tested for 2 hour floor ceiling assemblies, and those are red in color. The FF109X is actually the model number for those. If you ever see a gray or a black, at least as of now, gray or black TenMat cover in a roof ceiling assembly, i.e. in an attic, it's probably not correct. Just FYI. And then there's other things, plumbing and such, that exits the wall cavity. You got sink drains and supply lines and showers, the controls, the valve controls, clean out covers, all that kind of stuff that you see. You don't even think about all these pipes that stick out of the wall to plumbing fixtures. Well, they're all penetrations. They're all membrane. They're all coming down to that one side. They all have to be fire stopped. If it's a bearing wall, or if it's a barrier and such, and that's no discussion. But all the exterior walls, typically, most of them are in a one-story wood building, are bearing, and bathrooms end up on the exterior wall all the time, or in the corridor wall. The bathrooms in a nursing home end up on the corridor wall, and so you end up with a lot of penetrations that get forgotten and end up having to be fire stopped as an afterthought, which is not the appropriate way. HVAC registers and grills, all your air devices and the ends of the your ductwork terminates at the ceiling. Those are all holes, and every single one of those creates a hole, and so you have to have a radiant ceiling damper or some other protection too. And typically it's a radiant ceiling damper to protect the openings created by those that ductwork or those air devices. Other such things, recessed fire extinguisher cabinets, very, very common, or semi-recessed. And so they make rated ones. The rated ones are actually a component of a fire stopping assembly. So if you go look up under Jail Industries or any of the other ones, manufacturers that make them, you'll find that the product itself is actually not rated on its own. It's actually part of a fire resistive or a fire stopping assembly. Medicine cabinets, can't say I've seen a rated medicine cabinet yet, so you have to create, you need to be very careful about how that's detailed. Putting in medicine cabinets or Alzheimer's facilities, memory boxes, etc. Recessing them into the wall creates a hole. Toilet tissue dispensers. Oh, people forget about this one. Yes, it's very nice to have that recessed toilet tissue dispenser, so it's not sticking out nearly as far from the wall, but it's a hole. And I haven't seen a rated one yet, especially the plastic ones from Lowe's or Home Depot or any other, online kind of place. So you have to box out around it and continue the rating around it if you can, like on a bearing wall. You get to a barrier, it may not be possible because there's no such thing as a 1 hour fire stopping assembly that just has one layer of chipboard behind it. Sprinkler pipes extending through the ceiling that have the pipe sticking down, those have to be fire stopped. If this is out of the IBC, sprinkler heads that have a solid metal escutcheon that covers the hole, entirely covers the hole, are actually exempted under the building code from requiring additional fire stopping. And I guess that makes some sense since you're putting a sprinkler head right in front of the hole. But if the hole is larger than the escutcheon, or the escutcheon actually has vents in it or holes in the escutcheon, per some authorities having jurisdiction, such as DADS, have ruled that holes in the escutcheon means it's not solid and therefore does not meet the exception, and you have to fire stop it accordingly. And then there's other things such as structural expansion joints. So this is a good long list, and there's a lot more detail going to talk about how to protect these. And that, like I said, that's a whole another presentation. But you've got to really be cognizant of there's a lot of ways that these assemblies can be destroyed by putting holes in them, and those all have to be appropriately addressed and protected. If you want to go and find information, and I'm just addressing UL here, but you've got Factory Mutual, FM, FM Global, as well as Intertek as their common testing agency. And UL is the most widely known. There's nothing in any code that says, oh, you must be UL. No, it says you must be tested, it must be listed, or it must be classified. That means that it has to be done by a testing laboratory. UL happens to be one of the most worldwide, most well-known worldwide for doing such thing. If you go to ul.com, and I'm hoping that this hasn't changed since the last time I actually did it. This screenshot was taken in 2011, but it still should be about there. Where if you click on down at the bottom, you should be able to get the online certifications directory. Once you hit that, it actually takes you to their directory, which is a basic search engine. There's a number of things on here that actually are pretty able to see. You can, right here by the keyword, you can actually enter, if you're looking for P522 or U301 or one of these assembly numbers, just type it in. If you're looking for, let's say, fire-rated luminaires, and you have to know some of the terminology. Light fixtures is not going to be in here. They're actually called luminaires as the technical term. If you're looking for putty pads for the fire resistive the clay pads and such, they're intimate material that goes against the back of electrical boxes. They're actually under wall opening protectives, and so if you just look up putty pad, you probably may or may not find it. And if you're going to do more than one word, you need to put "and" between each individual word that you're searching. If you do any commas or any spaces, it won't find it. And then you can search by company, you can search by region, etc. But I have found that the keyword search generally works the best. There's also some quick guides and such that tell you about how the directory is organized. And then actually in newer versions of this, there's actually some really good fire stopping search engines, as well as fire resistive assembly searches that you can use on this. And Intertek sites very similar. It's a little more complicated, just in my opinion, because they have a lot more trademarks. They have Warnock-Hersey, and they have all these other trademarks that they've accumulated, or they've bought out other testing agencies. And so first you have to sort of know, which one am I going into? What am I looking for? It gets a little bit more complex, but they actually test. Intertek is who I'm talking about. They actually test more, or some things that UL does not, such as access doors. If you're looking for a fire-rated ceiling or floor access, or wall or floor access door, you're not going to find it on UL. Not very easily, and very few of them at least. But whereas Intertek or Warnock-Hersey's label, they're the ones that do the majority of the access doors that I've seen. Doors in general, actually, you're going to end up, you'll find a lot more of them with Intertek and Warnock-Hersey. And then when it comes to sprinklers, FM does a lot of testing for sprinklers, so their listings are there. Depending upon the product you're looking at, it may be on UL and maybe on another testing agency or in their directories, because that's who the company that made it went to test it and paid to have it tested. So I hope this was informational for you. There's so much more information. This particular presentation could actually last about 2.5, 3 hours to really go through in detail. And this also does not cover fire barriers, smoke partitions, firewalls, etc. in detail. So there's so much more information to go over. And I hope to get to some of those specifics on those topics in later presentations. Fire stopping, just the protection of electrical boxes. I mean, there's a lot of stuff that I hope to get to in later presentations. Thank you again for watching and listening, and we'll see you next time.